class we are discussing about real depth and apparent depth. So in our case we took this as liquid. It is a denser medium. In compared to the object was lying in a what medium? Denser medium. And the observer was lying in a what medium? Rarer medium. Okay, it more liquid but water low body. So yet my sokudi maniki. The observer is lying in what medium? Air medium or rarer medium, while the object is lying in the denser medium. In this case, okay, in this case, the image is the image is raised up. So where will the observer see the image? Yat dekhibo, ne tolot dekhibo, ne upor dekhibo. Upor dekhibo. Etu moi regam bonai disilu. Keneke bonaisilu mon ase ne? Eta moi eneke dilu straight. Eta kunphale goisile eneke. So yat normal draw korisilu. So this ray is now going from denser medium to rarer medium. So it will deviate away from the normal. So these two rays will never meet. Okay, so to make them meet you have to produce it backward. So at this point you are getting an image which is virtual image. আৰু এটো কয় নরমাল শিফট ইয়া পা ইয়ালে যে উঠি গল ইমান কিমানখিনি উঠি গল এটো কি বুলি কয় নরমাল শিফট বুলি কয় ওকে সো দিস ইজ দি ফার্স্ট কেস এটো কেস নাম্বার 1 কেস নাম্বার 1 ত কি আছিল লাইট ইজ গোইং ফ্রম ডেন্সার মিডিয়াম টু রেয়ারার সো ইয়াত কি লিখিলো কেস 1 ত লাইট traveling from denser to rarer medium. Yet light traveling from denser to rarer medium. Aru formula to dite ki ahi goisile eta ta kaam kori paro etu jodi refractive index mu2 naam de dilu etu refractive index mu1 naam dilu jodio air mo naam to ki disu mu1 eta formula to ki mor khodai mor rakhibi. Here the light is going from this medium whose refractive index is mu2 to another medium whose refractive index is mu1. It equation to keneke likhi mor rakhibi othamote jitu medium pa light jay that will come here in the numerator aru jitu medium or light jabo tar refractive index to enake tolot ahibo buji pachane the light traveling the light is moving traveling from this medium to this medium. Okay, this medium has got refractive index of mu2 and this medium has got refractive index of mu1. Gotike mu2 to what thakibo in the numerator and mu1 will be in the denominator and this is always equal to ki depth real depth by apparent depth. So a formula to enake mon rakhile hol tamane jitu medium opora jabo light to hey medium to refractive index numerator thakibo ne denominator thakibo numerator thakibo aru jitu medium or light goise tar hey medium to refractive index kunto ko thakibo denominator thakibo ei concept to more thakibo lebe ji kun problem koribo paribe tetia ketiaba case etu hobo pare sometimes suppose this can be like this also suppose eta moi enake di diu yat moi loi lolo it was water. This is water day. Water object to yata ase kobat. This is water. Aru upor ma glass or tukra ta dilu. Eto eta glass or tukra. This is a glass. Now suppose the observer is inside the glass medium. Ebar manutu jitu observe korise he kor ase glass medium or ase ya tamle sokutu moi yat di dilu. Wait. Okay, aru a object to yapra real depth kiman d real depth d. Now tell me light ray will be traveling from what medium to what medium? Rarer medium, optically rarer medium to denser medium. Yet ki hoisile it is traveling from denser medium to rarer medium. So it whole case 2. This is case 2. Yet ki hoise light is traveling from rarer to denser medium. Light rarer fra denser medium ole goise. Eta ray diagram to keneka akim. Prothom ray dal keneke loy always ki incidence নৰ্মেল ইনচিডেন্স সো ডাইৰেক্ট চকুত সোমাই গ'ল এটো গ'ল এনেকৈ গ'ল নেক্সট অকমান বেকাকে লওঁ এটো ইয়াৰ এটা নৰ্মেল ড্ৰ কৰ নাও টেল মি at this point there will be a refraction why the light is going from one medium to another the refraction to kumphale hobo it will bend away and it will bend closer to the normal why it is going from rarer medium to denser yet ki hoisile it is bending away from the normal yet okoman close hoi jabo ei phale okay but still this two ray will never meet it straight goise মানে এটো এফালে কত গুছি গল these two rays still will never meet so again to make them meet what you have to do produce them backward so backward কইলো সা এই টু backward কই দিলে এইখিনি মানত কোবাত মিট হ'ব now which is the apparent depth from here to here apparent depth কমি গল নে বাহি গল ইয়াত কি হৈছিল apparent depth এটো apparent depth d dash এটো কি আছিল real depth d okay here the apparent depth has reduced here the apparent depth has increased it's important kotha so it d or it ki d akilo so this is case 2 ketiba problem etu paibo ketiba problem etu paibo but still listen still the formula will be same ki mon rakhibo laibo jitu medium por light ahibo he medium to refractive index kot thakibo numerator ko কোন ইয়াত ধৰি ল মিউ কি নাম দিম মিউ 2 বুলি দিছো এটো মিউ 1 টেল মি দি ফৰ্মুলা গৈছে কবৰা মিউ 2 going to which medium this medium refractive index mu 1 is equal to d by d dash the formula is the same okay lock it there Kalyan Monarchy, here the apparent depth has increased, but here the apparent depth is reduced. In both the case, the formula is the same, but the position of the apparent image will be different. In one case it is reduced, in the other case it is extended. Hold, etia muk kosom. Suppose this is a river, and there is a man, Manueta, there is a person inside the river, at a depth d, and he sees a bird. And a soya raki di soriat, it was a sorai door. Megaki sole to sorai aru sorai to yar ase no to depth yes from the water level the bird is flying at a height of kiman d the bird okay if this man view this bird will he see at this position itself or downward no upward why kenaka kim light ko ba ki medium light aibo this is air medium and this is water medium so light is coming from east yak dekha pabole hole the light has to come from the bird to the man so the light is coming from rarer to denser so eta straight dide straight etu ki incidence boli koy normal there will be no deviation so straight sokot khumai gol aru eta kon beka ke dide enake yat normal da draw koi de so now this ray is coming from rarer to denser it will now bend close to the normal so okoman ei phale gusi gol goi bole sokot khumabo ge duta so ki koim but this two will never meet they can never meet so what you have to do just produce it backward ei to sa ei kini manot meet koris so this man in which is inside the river will observe this bird not here he will see somewhere at this position so bird to height bahi goise na komi goise as seen by the person bahi goise so this is the it was an object it was বুঝি পাইছ না তেনেকুৱা কথা কিন্তু বাৰ্ডটোৱে মানুহটোক ক'ত দেখিব ইয়াতে দেখিব নে এইখিনি দেখিব এইখিনি দেখা পাব ekada bostu okoman beleg, but the bird will see the man somewhere little bit raised. Right? Because in this case the light is going from denser to rare. I dekha pabole hole light to manu to pura goi pele yak kumaboge lagib. Right? So the light has to go from denser to rare. Denser to rare mane kuntu case? Etu case. Right? Aru I sorai to manu to dekha poa case to ki? Sorry, manu to sorai to dekha poa case to kuntu. So etu bostu de. এইবিলাক কম্পিটিটিভ পৰীক্ষাবিলাকত বেছিকৈ সোধে এনেকুৱা ধৰণৰ কুৱেশ্যন হায়াৰ ছেকেণ্ডেৰীত ইমান টাফ কুৱেশ্যন নোসোধে চিম্পল দিব বেছিকেলি এইটো পেটাৰ্ণৰ অংক বেছিকৈ সোধে গতিকে কিন্তু কম্পিটিটিভ এক্সামবিলাকত দুটা পেটাৰ্ণ লাগিব both the cases you have to know both the cases next আৰু এটা বস্তু লিখি লওঁ ৰিলেশ্যন বিটুইন ইয়াৰ ৰিলেটেড কিছুমান প্ৰব্লেম হয় ৰিলেশ্যন বিটুইন refractive index and wavelength of light for a pair of medium দুটা particular medium karone ami eta relation liabo lage you are asked to find a relation between refractive index and wavelength uliable for a particular pair of medium sabhage khunilo etu important suppose this is the interface nam didilo xy which is separating two medium etu medium or nam didisu medium 1 etu medium or nam didisu medium 2 consider this medium is rarer and this medium is denser. I am just considering. Refractive index of this medium is mu1. Refractive index of this medium is mu2. Velocity of light in this medium is v1. Velocity of light in this medium same or different? Different. Which is more? Which velocity is more? v1 is more, no, v2 is more. v1 because velocity of light in rarer medium is always more than in denser medium. So here v1 is greater than v2. Okay? Etia moi eta light source etu normal di dilu aru eta light source le lelu. This is the source of light. So from which we take an incident ray. Now any light has got wavelength and frequency. Any light has got key wavelength as well as key frequency. Etia eta kotha more rakhibo laibo when light comes from one medium suppose etu enaka aihol dei because it is coming from rarer to denser it is moving closer to the normal ek hol what ray is this incident ray what ray is this refracted ray clear hol ei ray to wavelength suppose moi nam di dilu lambda 1 incident ray to wavelength kiman lambda 1 incident ray to frequency nu okay so refracted wave to frequency ki hobo formula ki asile velocity is what asile light is actually what electromagnetic wave. Light is actually what? Electromagnetic wave. Any wave, the velocity of any wave has a particular equation. What is it? V is equal to frequency into the wavelength. What power is velocity of any wave, either it be mechanical wave, either it be electromagnetic wave, its velocity is always represented by this formula. It is the product of wavelength and frequency and wavelength. এতিয়া মই দেখিবি যেতিয়া লাইট এটা মিডিয়ামৰ বা বেলেগ মিডিয়ামত সোমায় তাৰ ফ্ৰিকুৱেঞ্চি কেতিয়াও চেঞ্জ নহয় কি চেঞ্জ নহয় ফ্ৰিকুৱেঞ্চি that you have to always remember whenever light enters from one medium to another medium its frequency always remain same তাৰমানে ইয়াত যদি ফ্ৰিকুৱেঞ্চি নিউ ইয়াতো ফ্ৰিকুৱেঞ্চি কিমান হ'ব নিউ but what will change because velocity change হৈছে this is constant which should change wavelength must change. বুজি পাইছানে? হয়নে? Why? Because when light enters from one medium to another medium, velocity will change. Frequency will never change. So what should change? Wavelength must change. গতিকে এই refracted wave-টোৰ wavelength same থাকিব নে different হৈ যাব? Same নে different? Different. কি নাম দিম? Lambda 2. হয়নে? এতিয়া এইকেইটাৰ মাজত ৰিলেশ্যন উলিয়াব লাগে, এইকেইটাৰ মাজত। আগতে আঁকি লোৱা, এনেকৈ আঁকি লোৱা ডাইৰেক্ট। খালি কি মনত ৰাখিব লাগিব? So what point you should remember? When light travels from one medium to another medium, its frequency is always constant. Always constant. Its frequency is always constant. Always constant, but its velocity and key wavelength changes. Velocity and wavelength changes. যেতিয়া লাইট পানীৰ পৰা সাপোজ গ্লাছত সোমালে, ক'লে সোমাইছে পানীৰ পৰা গ্লাছত, কি চেঞ্জ হ'ব? ৱেভলেংথ চেঞ্জ হ'ব। আৰু কি চেঞ্জ হ'ব? স্পীড চেঞ্জ হ'ব। কি চেঞ্জ নহয়? ফ্ৰিকুৱেঞ্চি চেঞ্জ হ'ব। চ' এইটো ফ্ৰিকুৱেঞ্চি অলৱেজ constant. It's always constant, but its velocity changes. Okay? Rakilo? এতিয়া মই এনেকৈ পঢ়াই আছোঁ দেই, নোটছত দিয়া নাই আৰু যিখিনি দিম এনেকৈ লিখি দিম আৰু। এতিয়া এই পইণ্টত স্নেলছ ল এপ্লাই কৰি দিম। ছাপোজ দ্য পইণ্ট ইজ পি। এট দিছ পইণ্ট ইউ এপ্লাই স্নেলছ ল। স্নেলছ ল নহয় এনে ৰিফ্ৰেক্টিভ ইণ্ডেক্সৰ এটা ফৰ্মুলা আছিলে, আমি এইটো লিখিব পাৰোঁ। মনত আছেনে? ক'ব পাৰিবি কি মিডিয়ামলৈ আহিছে? Second medium. Light is traveling to what medium? Second medium. Coming from what medium? First medium. আমি কেনেকৈ লিখিম? Refractive index of 2 with respect to 1. এটা ফৰ্মুলা আছিলে কি? V1 by last classত আছিলে V1 by V1 to কি? Velocity of light in first medium divided by velocity of light in second medium. So divided by V2. Okay? This is equal to velocity means product of wavelength and frequency. First medium what? Frequency kiman? Nu. Wavelength kiman? Lambda 1. So enake likhi lo. Lambda 1 nu. Divide by, in the second medium, wavelength is lambda 2. Frequency is same, nu. So frequency cancel, thaki gol lambda 1 by lambda 2. Now this equation can be also written as refractive index of 2 with respect to 1. Next class, this is the formula, is equal to mu 2 by mu 1. That was explained in the last class. So lambda 1 by lambda 2. This is the formula. So this is the relation between refractive index by absolute refractive index for a pair of medium with respect to its wavelength of light. এতিয়া অকমান নিউমেৰিকেলছ কৰি লওঁ দুটামান। So take the problem. A film of oil of refractive index, a film of oil of refractive index 1.20 lies on water of refractive index 1.33 full stop. The ray of light is incident at 30 degree. The ray of light is incident at 30 degree in the water on the oil water boundary. Full stop. Calculate the angle of refraction. In oil. So moi prothomte diagram eta banai loisu. This is the interface, naam disu xy, which separates two medium. One medium is oil. Oil to kot ase pani upor. Suppose this is oil. This medium is oil. Hey, this is oil which is lying over water. This is water. Water is water. Okay. So water mu w. Water refractive index is 1.33. আৰু যেটো oil লৈছে তাৰ refractive index দিছে mu oil mu বুলি দিছো mu liquid দিলে হ'ব mu l means mu liquid is equal to 1.20 ds. Okay, so this is the oil which is just floating or lying over water. এতিয়া কি কৈছে a ray of light is incident at 30 degree. ইয়াত মই normal draw কৰিলো. A ray of light is incident at 30 degree in the water. কোনটো মিডিয়ামত ইনসিডেন্ট কৰিছে water তাৰমানে এনেকে 8. The angle of incidence is 30 degree. Okay, so সুধিছে what is the angle of refraction in oil? Now tell me here which medium is denser and which is rarer? What? Oil is more denser. Why more denser? Your refractive index yatke besi. Refractive index jimane besi hoy, that medium is more denser in comparison to the other medium. So light is going from denser to rarer. Here it will bend. Light is going from what medium to what medium? From denser medium to rare medium. Denser पर rare लेके चलना है. Denser पर rare लेके लिखी है. It deviates away from the normal. So if it is, right? तो होने ना हो. ये तो की medium? Denser. Which is more denser? Water is more denser. Why? The refractive index of water is 1.3. The refractive index of the liquid is only 1.2. So this is more denser. It is denser medium. It is key medium, rarer medium. Light is traveling from denser medium to rare medium. Okay? So it will deviate away from the normal. Suppose the angle of refraction is R. R2 level. You are asked to find this value of R. Key koim direct key law use korile hoy jabo. Snell's law. Directly apply Snell's law. Therefore, by Snell's law. You directly apply Snell's law. Tell me, water to oil. So what you have to write? Snell's law will be refractive index of oil. Oil means liquid with respect to water. It will be equal to sin I by sin R. So by using this formula, you can write refractive index of absolute refractive index of liquid divided by absolute refractive index of water is equal to sin I. Sin I is sin 30 divided by sine r. Absolute refractive index of liquid is given as 1.20 and that of water is given as 1.33, which will be equal to sine 30. 1/2 sine r. 1/2 sine r. Therefore, sine r আমি উলিয়াব লাগিব. Sine r will be equal to 2 into 1.33 divided by 1.20. No. কিমান হ'ব? 1.33 divided by 2 into 1.20. So this is equal to 1.33 divided by 2.40. 1.33 divided by 2.40. 1.33 divided by 2.40 is equal to 0.5541. Therefore, R will be equal to sine inverse 0.5541. So either using log table or calculator, you can find out this value. Sine inverse of this mass will be something kiman hobo 33 মান hobo niki approximately. 30 কে ভালকে চাই লবি 33 ডিগ্ৰী মান হ'ব লাগে. So ইয়াত কি মনত ৰাখিব লাগিব এইটো একদম সবে মনত ৰাখিবি যে যেতিয়া লাইট যিটো মিডিয়ামৰ পৰা যিটো মিডিয়ামলৈ যায়, okay, here it is going from water to oil. So what you have to write? Refractive index of oil বা liquid with respect to water. যিটোলে যায় সেইটো তলত আৰু যিটো পৰা আহে সেইটো ওপৰত. এটা একদম পুৰা মাথাত সোমোৱাই ল, উল্টা হৈ গ'লে এনসাৰটো ৰং হৈ যাব. Okay, so একদম মাথাটো স্থিৰ কৰি পেলাই অংকবিলাক কৰিব লাগে. So take another one. A light of wavelength 6,000 Armstrong. On ho gol niki? A light of wavelength 6,000 Armstrong. 6,000 Armstrong in air enters a medium of refractive index 1.5. Enters a medium of refractive index 1.5. Full stop. What will be the frequency? What will be the frequency and wavelength of light in that medium? What will be the frequency and wavelength of light in that medium? It is a whole problem. So in the question it is given that light enters from air medium to another medium. Suppose this is air medium, this is another medium. It's a medium, medium. So this is the normal. So light is entering from air to medium. So it is not said which is denser or which is rarer. Suppose I am considering this as denser and this as rarer. It is rarer air medium. So definitely this medium is more denser than this. So light is coming from rarer medium to denser medium. It will bend close to the normal. এটা কৈছে যেটো লাইট ইনসিডেন্ট কৰিছে সেই তাৰ ওয়েভলেংথ, the light which is incident is having a wavelength of 6,000 Armstrong. Now the question is, what is the frequency and wavelength in the medium? এই লাইটটো রিফ্রাক্টেড লাইটটোৰ কি কি উলিয়াব দিছে? ওয়েভলেংথ আৰু ফ্রিকোয়েন্সি. What will remain same? ফ্রিকোয়েন্সি. ইয়াৰ যদি ফ্রিকোয়েন্সি নিউ, ইয়াৰ ফ্রিকোয়েন্সি কিমান? নিউ. এখানে মই প্ৰথমতে কি কৰিম? এই লাইটটোৰ ফ্রিকোয়েন্সি উলিয়াই ল'ম. লাইটটোৰ কি উলিয়াই ল'ম? ফ্রিকোয়েন্সি. Now tell me, what is the velocity of light in this medium? Air medium. Air medium or velocity of light কি হয়? C my velocity of 3 into 10 to the power 8 meter per second. So which relation you have to use? velocity is equal to wavelength into frequency. So first of all, you find out frequency. Frequency equals c by lambda. C is given 3 into 10 to the power 8. Lambda 6000 Armstrong. Armstrong mane into 10 to the power minus 10. So if you solve it, what you will get? 3 into 10 to the power 8 divided by 6 into 10 to the power minus 7. Etu bole gusi gole kiman hobo? 1 by 2 into 10 to the power bole gusi gole minus 8 plus 15 or 0.5 into 10 to the power 15. That I will did you 5 into 10 to the power 14 hertz is the frequency of the which ray? Incident ray. Eta ki likhibo laibo? Ki likhibo laibo? Since the frequency of light traveling to any medium is always constant. Since the frequency of light traveling to any medium is always constant, therefore frequency in the other medium a medium to same. So nu is also equal to same. So 5 into 10 to the power 14 hertz is the first answer. Kintu ki change hobo? Wavelength. Right? Wavelength change hobo. Ekhane etu naam dide lambda dash. The wavelength will change. So to find that wavelength, eta formula disilu etu formula. You can use this formula. So you can use this formula. Therefore, by relation, what relation? Mu2 by mu1 is equal to eta khali eta katha lambda 1 by lambda 2. Etu formula use korim no. So you use this formula. Etu tamane mu1 etu mu2 jodi dhoru. So ki hobo? mu2 ki refractive index of the other medium. This is 1.5. So ki likhibo laibo? 1.5 divided by mu1. Mu1 is the refractive index of air. How much is the refractive index of air? 1. It is the lowest. Refractive index of air is always lowest. So here 1 likhile hobo. 1 is equal to lambda 1. Lambda 1 to kuntu etu ki naam to mu1 lambda 1 to lambda 1 mu2. So lambda 1 is how much? 6000. Okay? Divide by lambda 2. No ulta hoise ni? ঠিক আছে inversely proportional হৈ আছে. Therefore lambda 2 will be equal to 6000 by 1.5. 6000 Armstrong নহয় জানো? Armstrong হলে কি হ'ব? into 10 to the power minus 10. So to calculation for 6000 divided by 1.5. 4000 into 10 to the power minus 10. That means 4000 Armstrong is the answer. Clear hoise ne? Ki more rakhibo laibo? When light travels from one medium to any other medium, frequency will always remain same, but the wavelength will change. Also, the velocity will change. there is a question given in the textbook. Eta textbook or problem eta korsu. Take the question. A tank TNK tank is filled with water. A tank is filled with water to a height of 12.5 centimeter. To a height of 12.5 centimeter. Full stop. The apparent depth of a needle, lying at the bottom of the tank, is measured by a microscope. At the bottom of the tank is measured by a microscope to be 9.4 centimeter. To be 9.4 centimeter. What is the refractive index of water? To be 9.4 centimeter. What is the refractive index of water? If water is replaced by a liquid of refractive index 1.63 up to the same height, comma, up to the same height, by what distance would the microscope have to be moved to focus on the needle again. To focus on the needle again. So, in the question it is given that there is a tank. A container. Jot ki ase boli koise water, filled with water. Etu level olike water ase boli dhor. Water. To a height of 12.5 centimeter. Water to height kiman koise 12.5 centimeter. Okay? The apparent depth of a needle. Down here jodi eta needle ase, etu eta needle. Eta upor pa saute. Prothom kotha ko, needle to kot dekha pam. If you view the needle from the top, okay, you will see the needle here or below or upward. Why? The light ray is traveling from denser to rare medium. So light to enake he jabo. Otike yat kobar dekha pam. Image to yat dekha pam. It is suppose etu naam disu O dash. It koise the apparent depth of the needle lying at the bottom of the tank is measured by a microscope to be 9.4 centimeter. With the help of the microscope, this image has been seen at a depth of how much? At the apparent depth of kiman dise 9.4 centimeter depth of a needle to dekha paise with the help of a what? Microscope. Okay, when the tank is filled with water. Okay, next question to koise or out of this next ako ki koise, if the same tank is filled with another liquid, belag eta liquid bhorai dise. Okay, belag eta liquid bhorai dise to same height mane water kiman height liki asile 12.5. So liquid is also 12.5 centimeter. মানে আৰু সেই লিকুইডটো কি দি আছে ৰিফ্ৰেক্টিভ ইনডেক্স হাউ মাচ the refractive index of this liquid is L লিখিছো is how much 1.63 আৰু ইয়াৰ কিমান দিছে water water টো উলিয়াব লাগে নেকি so এটো উলিয়াব লাগে so first এটো কৰি লওঁ so first question is what is the refractive index of water what is the refractive index of water কোনটো ফৰ্মুলা ইউজ কৰিম কি মিডিয়ামৰ পৰা কি মিডিয়ামলৈ গৈছে ইয়াত কি মিডিয়াম এয়াৰ মিডিয়াম ফৰ্মুলাটো হয় না লাইট কেনেকৈ যাব এইটো মিডিয়ামৰ পৰা এইটো মিডিয়ামলৈ যাব সব কি কৈছিল ফৰ্মুলাটো মিউ যিটো মিডিয়ামৰ পৰা যায় তাৰ ৰিফ্ৰেক্টিভ ইনডেক্স কোড আহে নুমেৰেটৰ সো ইয়াত কি লাগে মিউ water going to what medium air so mu a is equal to real depth by apparent depth এই ফৰ্মুলাটো তেনেকৈ মনত ৰাখিবি তেতিয়া সুবিধা হয় কৰিবলৈ so mu water ওলাই যাব therefore mu water refractive index of water will be equal to d by d dash into mu a d is how much d is eto real depth 12.5 apparent depth 9.4 into refractive index of water air is always 1 so 12.5 divided by 9.4 1.32 like 1.32 asal 33 hoy at approximately 1.32 so this is the refractive index of water which is found in the first part the second part to key this there is another part in the question now the question is what the whole tank is now filled with another liquid whose refractive index is 1.6 okay needle to yate ase কিন্তু উপৰ পৰা চাওতে নিডলটো মই কোড দেখা পাম এটো লেভেলটো দেখা পাম নে তাতকে ওপৰত দেখা পাম নে তলত দেখা পাম আগতে হেতু কইলো কোড দেখা পাম এনে এটা ফৰ্মুলা দিছিলো refractive index of a liquid is always equal to with respect to air is always equal to real depth by apparent depth মানে এই দুটা কেছত what depth is same real depth you have to 12.5 you have to 12.5 real depth is same so this is constant so what refractive index is inversely proportional to key apparent depth I mean more is the refractive index less is the apparent depth less is the apparent depth ko here refractive index kiman paisu 1.32 এই লিকুইড রিফ্র্যাক্টিভ ইনডেক্স কিমান দিছে 1.6 ইয়াৰ রিফ্র্যাক্টিভ ইনডেক্স ইয়াতকে বেশি তাৰ মানে অ্যাপারেন্ট ডেপথ কম নে বেশি কম মানে এটো লেভেলত দেখা পাম নে ইয়াৰ তলত নে ওপৰত হাই অ্যাপারেন্ট ডেপথ কম মেজার হয় অ্যাপারেন্ট ডেপথ সারফেস অফ সদায় মেজার হয় হয়নে সারফেস অফ মেজার হলে অ্যাপারেন্ট ডেপথ কম পাইছো কম পোৱা মানে কি ইয়াত থাকিব নে ইয়াতকে ওপৰত থাকিব ওপৰত এইখিনি মান থাকিব এইটো হ্যাঁ ইয়াত থাকিব ইয়াত এটো ও এটো ইয়াত ও ডেস so when this tank is filled with this liquid of refractive index 1.6 which is slightly more than water the image of the needle will be shifted more upward হয়নে so এবাৰ মাইক্ৰোস্কোপটো ক'ত ফোকাস কৰিব লাগিব এতিয়ালৈকে ইয়াত মাইক্ৰোস্কোপটো ইয়াত ফোকাস হৈ আছে এবাৰ এই মাইক্ৰোস্কোপটো ক'ত ফোকাস কৰিব লাগিব ইয়াত হয়নে মাইক্ৰোস্কোপ এনে ফোকাস কৰি দিছে so the microscope has to be moved up and moved down উপৰৰ পৰা চাওতে আমি মাইক্ৰোস্কোপ লৈ পেলাই এই পইণ্টটো চাই আছো হয় এটা ট্ৰেভেলিং মাইক্ৰোস্কোপ বুলি কয় so with the help of the microscope it is now focused here biology lab microscope চাইছিলে নাই তললৈ নিব পাৰি the microscope can be slided down also it can be slided up etia microscope to yat focus hoy ase etu point of focus hoy ase kiman distance of focus hoy ase এইটো 9.4 ফ'কাছ হৈ আছে হ'ল এতিয়া এই ইমেজটো চাবৰ কাৰণে মাইক্ৰস্কোপটো মই ওপৰলৈ নিব লাগিব নে তললৈ নিব লাগিব ওপৰলৈ নিব লাগিব অলৰেডি ইয়াত ফ'কাছ হৈ আছে চ' মই ইয়াক চাবলৈ হ'লে অলপ ওপৰলৈ আনিব লাগিব চ' কিমান ওপৰলৈ আনিব লাগিব ইমানখিনি আনিব লাগিব হয়নে ইমানখিনি আনিব লাগিব তাৰ আগতে কি উলিয়াব লাগিব এইটো উলিয়া এইটো ডি ডেছটো উলিয়া হাউ উইল ইউ ফাইণ্ড ডি ডেছ second case when the tank is filled with another liquid when the tank is filled with another liquid যেতিয়া বেলেগ এটা লিকুইড ভৰাই দিলোঁ এতিয়া কোৱা ফৰ্মুলাটো কি লিখিম এই ফৰ্মুলাটো মিউ টেল মি ফটাফট মিউ ওপৰত লাইট ইজ গোয়িং ফ্ৰম what medium to what medium light is going from what medium to what medium from liquid medium to air medium so কি লিখিম ওপৰত mu l তলত mu a is equal to real depth by apparent depth okay so mu l দিয়া আছে mu l is 1.63 refractive index of air is always 1 is equal to real depth is দিয়া আছে 12.5 d dash to ওলাই যাব therefore d dash will be equal to 12.5 divided by 1.63 12.5 divided by 1.63 which is equal to 7.66 centimeter তাৰ meaning to কি এই লিকুইডটোত অ্যাপারেন্ট ডেপথ কিমান পাই গলো 7.66 এইখিনি পাই কিনে 7.66 এইখিনি কিমান হ'ব ক এইটো লেভেল দিছে ইয়াৰ পৰা ইয়ালে মাইক্ৰোস্কোপটো মুভ কৰিব লাগিব ওকে সো কি পা কি মাইনাস কৰিব লাগিব 9.4 এইখিনি পাই 9.4 হয় নে 9.4 minus 7.66 therefore the microscope has to be moved up through a distance is equal to minus 9.4 minus 7.66 9.4 minus 7.66 1.47 this is the answer to the textbook problem so sometime it may be asked